everybody. This is my final video 3 out of 3 for CTP2. Uh, Sky Mapper was my project for CTP2. So in video 1 I covered the backend, so stuff like custom Dijkstra algorithm and the hand-built data structures. In video 2, if I remember correctly, was front-end stuff like Streamlit, yeah, so Streamlit, which was Streamlit UI wired to a Plotly map. And then now this video is the reflection, wrap up, final status of the project, how it went against CTP1 plan, what I learned and where it could go from here, just the stuff from the outline. So yeah, so final status, I'll begin with final status. So SkyMapper is, I'm happy to say, is complete and also functional. Uh, The user picks an origin, destination, optimization criteria, and maximum stop budget, how many stops they want, how many stops they can afford, and then yeah, just their maximum amount of stops. So then the app runs a custom Dijkstra over a graph loaded from the OpenFlight's data, data which was from the OpenFlight CSV, and then returns the optimal route with the distance, cost, layover, count, and per leg breakdown as well. The route is drawn on an interactive Plotly world map as a great arc circle, similar to what you see on your screen. Um, and also very happy to say that all goals, apart from one, which was the live data, which is more of like a want more than a goal, but still, it was a goal which wasn't met. So yeah, apart from that, all the other goals were met. So custom algorithm, custom data structures, um, you know, graph libraries and stuff like that, working web interface, all those goals. So that was pretty good. And also real world flight data was used, not just random data, real world flight data. It's it's unfortunate the live one couldn't be used, but yeah, still real world flight data was still pretty good. But yeah, so that's the final status. So yeah, progress against CTP1 plan. So CTP1 report broke CTP 2 into 3 phases, which was core development, development of interface, and polish and testing, and final testing. So each phase completed on video 1. So video 1 marked the end of phase 1, video 2 marked the end of phase 2, and then so each phase was completed on the scheduled video, if that makes sense. And now this video marks the end of phase 3. Um, so progress was good, but there was some deviation. Like the deviation from the original plan was that CTP1, like I mentioned before, was leaning towards using live flight data. That goal was unfortunately not met, but um, yeah, it was during my first phase I realized it was the right thing to do to stick to static data, static OpenFlight CSV, and because the reason being, if I did live data, it would have added a lot of scope creep as well, which wasn't quite good, and it didn't really improve the algorithm or the demonstration that much, if that makes sense. But yeah, so yeah, every project objective was satisfied. The objective was taken, process the routes with my algorithm, then produce the optimized solutions slash suggestions, and then obviously display them on the map similar to what you see here. So um, and which is also interactive as well. So all of those objectives were met, which I was pretty happy about. Okay, and now reflection. So this is the technical reflection. There will be two reflections, the technical and personal. So in reflections, so what worked? So building the data structures before putting them into the Dijkstra algorithm was very, very good. That worked very well. Um, so doing that in isolation actually before like connecting them to the Dijkstra was, wiring them into Dijkstra was pretty good. Um, unit testing the heap and hash table separately, caught bugs that would have really taken a lot longer and been more complex. Um, and yeah, just harder to find if I was actually tried to find them inside an actually running algorithm. So that was pretty good. I was pretty proud. That was pretty proud of that. The route that I picked there. Also choosing Streamlit, Python, that was pretty good as well. It kept things not like simple because it wasn't like crazy simple. It's just it wasn't too complicated. It was the right amount of complexity for me to actually learn and get to know things and work on it and make good progress. So yeah, so Streamlit, I'm quite happy about that technical decision. Development speed was also good as well compared to like what was it? Like Flask or something like that. So yeah, that's Flask, which would have been my alternative to build the front end stuff. So yeah, but there are a couple of things I would change though. So what didn't work was the so I'd cache. I've written here in my notes. I'd cache the base plotly figure separately from the route overlay. Reason being, the current version rebuilds the whole map on every rerun, which is fine on the sample data set, but it is very noticeable on the full one, and it gets pretty bad. So yeah, that's one thing I would say it didn't quite work. And yeah, again, live data again, um, that didn't work. So yeah. One other thing as well, I think I talked to Anurad about this. I don't know if I remember or not, but uh, the like there was a difference between how correct the algorithm and how algorithm correctness and dataset completeness were like two different things and two separate concerns. So Perth to Tokyo case and my sample dataset returned Singapore instead of Hong Kong, which is the real route. So my sample set I only had didn't even have Hong Kong. So yeah, the algorithm was correct, but my dataset wasn't complete there. So that was yeah, I was stuck in that for a little bit trying to figure it out. But yeah, that was fairly simple and kind of stupid, but yeah, lesson learned from there. So yeah. Personal reflection. So there's two main things. So I didn't quite understand this difficulty of working with the Dijkstra algorithm. Yes, I already had it from one of my previous units, which was approved um, by Jonas, which did my CTP one, so that I could work on CTP two. But even with that, I mean, it was still pretty complex. Just forced me to actually understand Dijkstra all over again. I thought it'd just be like, yeah, just get it and start going with it, but I really had to fully understand it because if I didn't understand it, then I didn't know if it was actually correct or not, if that makes sense. So yeah, just understanding Dijkstra and then actually just working on it wasn't the easiest. And I don't mean understanding Dijkstra itself was the difficult part. I just mean just working with it. And understanding was one of the parts, and actually working with it was the difficult part. But yeah, it was challenging, but it was good. So yeah, just the depth forced me to understand a lot. What was it? Hash tables, queues, graph traversals, and yeah, just stuff like that because I didn't use network X libraries either. So yeah, and also like the little like complexities as well, like not just the big ones. Like um, Dijkstra was obviously a big complexity, but even the smaller things, like there was a lot of headaches there. So I learned to also account for those type of things as well in the future and work with them. I wish I had written down an example, but yeah, just little stuff. So yeah, yeah, and after that, pretty much was just testing and polishing and deployment essentially. Just making sure everything is okay. So yeah, and after that, I just tested everything. Everything was like, plug in the data sets, do like real world examples, and just test everything. So yeah, I'm running out of time here. So yeah, future work. If project continues past CTP2, I would, swap static data for live flight data with API. I would extend criteria so it's even more customizable, which is pretty good. And then obviously I'll do public deployment as well. Um, but yeah, just make more, give people more options and have live flight data, which I would think is cool as well. But yeah, that's pretty much it. And thank you for listening.